I'm Aarav, and our group has created Keystone, an AI-powered key classifier. So the main task that Keystone accomplishes is that it can classify audio, whether recorded or clips, into either one of these four chords. So A minor, C major, F major, and G major. Now we picked these four chords because these chords seem to make up the majority of notes in pop culture music, so it'll be very useful. Now, this task brings a lot of use cases, especially for new learners and beginners in music. So, musicians who are, learning a new instrument, if they want to test their skills, see if they're playing their notes correctly, they can record a clip and put it into Keystone. If someone's trying to identify the keys of a song or chord, they can put that song into Keystone and see the chords that way. So our data set comprises of two parts. We have real data that's scraped from YouTube videos, and we essentially get the audio files from these YouTube videos and split them into 2-second chunks. We also have generated synthetic data, which we use NumPy and sine waves, sawtooth waves, and square waves to create this data. And we added a bit of randomness and variation just to make the data set more robust. We converted all this audio into MEL spectrograms, which you can see on the right for our model inputs, and we did an 80-10-10 split for training, validation, and testing. So these are the 5 models we trained with. To serve as a baseline, we used random forest and gradient boosting, and then we also trained CNN, and a CNN that also uses PyTorch's spec augment, which improves robustness to noise, dynamics, and other variations. We also trained an RNN, which is a sequence model that captures the temporal structure across the spectrogram frames. And we saw that this was the best performing model due to the explicit modeling it does with its LSTM layers of the musical progression. So here you can see our training and testing results. So for our training results, we have our baseline gradient boosting and random forest on the right, and we have our deep learning models on the left. So we see that RNN had the best validation accuracy at around 96.5%. And in testing, we see that the RNN also maintained the highest accuracy with around a 96.6% test accuracy, with the CNN having a 95.5% accuracy, and the augmented CNN, surprisingly, having a lower accuracy than the other deep learning models. And now let's show a quick demo. All right, so this is the front page of Keystone. We made a simple front end just so you can test everything and actually use the product. So first, let's test with this clip here, and this is an F major melody. So currently we're running it on our baseline random forest, and we see that predicted it accurately. Now, we can also test a different model, for example, gradient boosting, and we see it also predicted F major. And if we try it on the CNN, test it with the CNN, we see it also predicted F major. So we can see the spectrogram inputted in the bottom as well as the model's confidence in its prediction. Now let's try a different example. And this time we'll use the RNN. So if I put the whole song here, the Eagles, one thing that we actually noticed is that throughout the whole song, the RNN actually shows the distribution of the chords throughout the song, which we can see at the bottom. So we see the majority of the song had F major, while all the other chords had their own respective contributions. So that was just an interesting pattern we noticed while we were testing. Now, one can also record a clip straight into the microphone and get information that way.